Here are lots of examples of starts of triangle questions. So, what kind of triangle question is this? Pause the video, restart when you've decided. Is it a equilateral triangle? No. Is it isosceles? Oh yes, it is isosceles because those two angles are the same. The consequence would be that, for example, these two sides are the same, and we can also easily work out what the third angle is. Next, what kind of triangle question is this? Pause the video, try in your own time. Okay, they're not equilateral. They're not isosceles. Well, actually, they could be, but we don't have clear evidence. Is it similar triangles? Oh, yes, it is. So the first thing we will try and do is use similar triangle method. So, for example, if that was 4 centimeters, then we would just do 4 times 3 equals 12 centimeters to give, oops, that should have been centimeters, to give the length there. Then obviously if it was area, we would times by 3 squared. If it was volume, we would times by 3 cubed. Let's try the next question. What type of triangle question is this? Pause the video, try in your own time. Okay, it's not equilateral. Well, one of the sides are different lengths. It's not isosceles, or at least it's not obviously isosceles. There's only one triangle there, it's not going to be similar triangles. I don't know that there's a right angle, so it must be something else. Okay, given that it's something else, it's going to be using one of these three equations. Oh, right. It's not going to be the middle one because that involves three sides and one angle. Well, I suppose it could be, couldn't it? Because maybe they want us to find out what this length is. Because at this point we're making up a question. It could also be, so it could be that one, if you had to find out the extra length. It could be the area one. You could definitely work out the area of that triangle. Yeah, let's stop there. What type of triangle question is this? Pause the video, try in your own time if you like. Okay. Oh, it's an equilateral triangle question because they're all the same length, which tells us that all those angles must be 60. And we don't really know what we need to do with that, but that's obviously the skill we'd use there. What type of question is this? Have a go in your own time. We don't know that they're equilateral triangles, although I think they could theoretically be. Oh, well they are isosceles triangles because these two lengths are the same, which means that those two angles will be the same. Which means you only need, you only need one angle to then find out what the other two are, all that kind of stuff. I would personally use my isosceles triangle skills first, before then using the fact that they're also similar triangles. Because generally that will save time and for other good reasons as well. What type of question is this? Well, it's not a equilateral triangle, it's actually a cross. It's not isosceles, not as far as we can tell. Ah, but it is a right angle triangle because I can. Sorry, it's not similar triangles. Oh, but I can see a right angle because there's obviously a right angle there. So it could be SOHCAHTOA or it could be Pythagoras. This one looks like it might be Pythagoras because you could use a squared plus b squared equals c squared. So you'd have 3 squared plus 4 squared equals 5 squared, and then if you equals c squared, and if you do the maths, it turns out, do a bit of rearranging, you end up with c equals 5. Blah blah blah. Let's do the next question. What type of question is this? Is it an equilateral triangle? Nope. Is it isosceles? Not as far as we can tell. Is it right angled? Actually, I don't need to say it, not as far as I can tell. It can't be because this is 110 degrees, which means there's only 70 degrees left. So none of the angles can be 90. So it's definitely not right angled. Well, I've just done it in the wrong order again. Always doing that. Number 3 is similar triangles. Is it similar triangles? No, it's not. There's only one. Is it right angled? Now it's not right angled. Okay, which means it's going to have to be one of the remaining ones. Sort of probably using one of these three standard equations. Well, it could be cosine rule because that would involve 1, 2, 3 sides and an angle. So maybe they want us to find out what this angle is. Or it could be area. It could be sine rule as well, but that would be a bit weirder because we don't have either of the opposite angles. But anyway, let's try next question. Pause the video, have a go in your own time. Okay. Is it a collateral triangle question? No, because at least one of the angles is not 60 degrees. Is it isosceles triangle? Oh, do you know what it is? So that's 45. Which means that we now know straight away that that's 7 centimetres. Just one example there of why we do it in this order. Because if you jumped in and done it as right angle triangle question, it would have taken a lot longer than spotting that it was isosceles. Anyway, just a nice example there. What type of question is this? Okay, is it equilateral? Excuse me. Not as far as we can tell. Is it isosceles? Well, this one is an isosceles triangle. Is it similar triangles? Yeah, not as far as we could tell. It would be similar triangles if, let's just change colour, if this angle turned out to be a right angle, but we don't know that, so we can't say that it is at this stage. But oh look, there is a right angle, so there's right angle. So it looks like it's a combination of two different triangles. Maybe we'd use different skills from both to finally answer the question. Let's look at the next one. Oh, it's asking for the area. Have a go at this in your own time if you like. I'm going to have a go now. Is it equilateral? Oh, it is. Which means I can say straight away that must be 10 and that must be 10. That must be 60. That must be 60 and that must be 60. Now, what is the area of an equilateral triangle? Maybe you have some fancy way of doing that. I don't have a way of doing that, so I'm going to have to carry on with the method, which is that you keep going. If you can't answer the question straight away, you just keep going with the method. Is it isosceles? Well, let's say no, although technically it is. Is it similar? There's no other triangles there, because if there had been, maybe that would have helped. Is it right-angled? No, and there isn't another triangle involved either. Okay, so presumably seems like a good chance it involves one of these three. Oh, it's asked for the area. Oh yeah, so we could use that. So then the area would just be a half 10 times 10 times sine 60. Stick it in the calculator or whatever, and you'll get an answer. Have a go in your own time. What type of question is this? It's not equilateral because one of the angles isn't 60. As far as we can tell, it's not isosceles, but we obviously can't be sure. But unless we can be sure, we can't use the rules. Is it similar? No, there's only one triangle. Is it right-angled? Well, we can't see. We don't know for sure, therefore we can't use the rules. So it's going to have to be what? Well, I don't like to say it has to be, but probably it's one of these three, or go back to the start, or maybe it's not a triangle question at all. So in this case, this is an example of where it might be sine rule, because we could call that A, and call that A, and call that B, and call that B, and then you've got two sides and two angles. But clearly I've just made a question up because it didn't originally say what the question was. Who knows, could be something else. Let's try the next question. What type of question is this? Okay, it's, as far as we can tell, it's not equilateral. Oh look, it is isosceles. Commonly people don't spot isosceles if they're on their side, or often the most common isosceles, if you ask someone to draw one, in my experience, is they draw one that looks like that. But obviously, that is also an isosceles triangle. Even though the top angle is very large, it's still actually isosceles. So this here is an example of an isosceles triangle, because we know those two are the same length, which means we also know that those two angles are the same. I've not written a full question there, so we don't really know what we're supposed to do with that information, but in a maths question that would presumably have been important. What type of question is this? Okay, we don't know for sure that it's equilateral, so we can't say it's equilateral. Can we say for sure if it's isosceles? Nope. Can we say for sure if it's similar? Yes, we can. Reason is because it's an enlargement, which means that each thing has been multiplied by the same amount. So it has a scale factor, so we could describe a scale factor. Do you know what I would do? Is I would probably actually redraw this if I was doing a question like this, because I like to have a system that I just follow every time. Just makes it nice and safe, so I won't make any silly mistakes. I don't need to keep making up new methods for every question. I can just slip into the same techniques. So I draw them side by side, write a times k, and then do some maths. Let's try the next question. What type of question is this? It's definitely not equilateral because I can see non-60-degree angles. I don't know for sure that it's isosceles. I don't think it is actually, because presumably, because of the way they've labelled up, they probably would have told us if that was the same length, same as well. If you don't know that, it might turn out it is, and whoever set the question didn't realise. Is it similar triangles? Do you know what it actually is? Because if I just move this one to the side, oh look, it's basically the same triangle, but it's a bit smaller, which is the definition of similar, which is that it's basically the same triangle but a different size. Have a go at the next question. As in work out what it is. It's not equilateral because I can see non-60 degrees. I don't think it's isosceles. It can't be similar. It's not obviously a right angled triangle. Maybe it's, so it'd be something else. And suppose I then try the question, actually that didn't work because I made a deliberate mistake here, so well done if you spotted my deliberate mistake. Actually, obviously 5 still applies. You can always use these equations for any triangle because they're true for any triangle. But anyway, this is actually right angled because if you add up those two, it comes to 90. And then if you do 180 minus 90, that's 90. So that actually is a right angled triangle. So that's kind of a right angled triangle question in disguise. There we go, and I've just run out of questions. Hopefully that was helpful. Maybe watch through it again, or find some real triangle questions, have a go at using this method. Thanks for watching.